The second step of digital encoding is entropy encoding. Let's take this. I'm taking a picture of myself, therefore I'm converting all of my parts into quantized chunks of data. Each of those tiny little chunks is converted into a symbol. The formula for entropy encoding, which is a way to create the entire picture, x plus y plus z, I suppose, and makes that into something much smaller that's still the same thing, or at least appears to be the same thing. When x happens, and then y happens, and z happens on the screen, these all happen separately mathematically as separate chunks. And entropy encoding, the negative log of the amount of symbols that we have after quantization. So in this case 3. And then we multiply that, so it's the negative log of the number of symbols multiplied by the probability of any of the symbols happening. So the output code for x, right arm, is the negative log of 3, x, y, z, multiplied by the probability of seeing x. X, my right arm, the one I think about the most, the one I use the most, the one I care about the most, obviously has the highest probability for me. Therefore, the entropy encoded symbol for x is the smallest of the 3 symbols, x, y, z. It would be inefficient to make y or z the smallest numbers because they don't matter as much. So if you can make the things that happen the most often the smallest chunks, you've saved an incredible amount of space. And that's the entire idea of video compression.